Hi, welcome to ADI Technical Training. I'm Matthew. Today I'm in our technical lab at our UK hub in Chadderton, Manchester. Okay, let's get started. In this video we're wrapping up the first half of the series of videos we're doing on access control. This is the final video where I'm going to discuss a controller, what a controller is, how it works and what it does, and the formats you can get it in. So I briefly mentioned controllers above a door. So you have a standalone system where the controller is built into the reader, and then you have secure PC-based or cloud-based systems which have a separate controller from the reader. The controller is the device which controls the input of data, so that's your credential, and it gives the output to the locking device, so it applies voltage. So if you present a valid card or fob to a reader, that information is transmitted to the controller. The controller decides, are you allowed in? Is it a valid card? Is it on a valid time zone? If so, it applies power to the locking device and the door will unlock and let you through. Door controllers come in a few sizes. The most popular thought nowadays is to have a single door controller. So adjacent to each door, you would put a controller there, take all your wiring back to that door, typically within 20 meters or so of the door, and make all your electrical connections there. It makes life easier for the installer. If you've only got a few doors to do, it makes life a lot easier to put the controller adjacent to the door, and then possibly, if it's a PC-based system, interconnect them or connect them through a local area network. Sometimes though you have a larger installation where you want to cluster doors together and you only want to, for instance, make one mains connection and you only want to use one network connection. And in that case you would either get a bunch of door controllers and put them in a single housing. So with some brands you can put 4 single door controllers into one metal box and in effect make a 4-door controller. Even though you have 4 separate controllers, you can do that. You can put 4 controllers in there, you can put a switch in there, and you could allow all these controllers to connect together to make one network connection. And you could also only have one mains connection, cutting down on electrical costs. Other vendors, on the other hand, they do systems which go larger. Some of them do 2-door controllers, some do 4-door controllers, and some vendors you can have up to 16 doors controlled from one central location. And that makes it sometimes a lot easier to do the configuration. It makes your life a lot easier if you can bring all your wiring back to one point, make all your electrical connections at that one point, and run it from a single mains connection too. It also possibly helps with fault finding. But there's no hard and fast rule. Whichever is best for the application is the best controller to use. If you have a PC-based system, there are many ways, well, 2 or 3 ways you can connect to that controller. How do you share that information between them? So previously I mentioned that on a PC-based controller, a computer sends all the information out to the controllers and it's distributed evenly between them. How's that information sent? Now it can be sent on what's called an RS485 bus. So from the computer, from a hardwired connection from the computer, a cable is run to the first controller, the information is sent there, that controller then sends it to the next one, to the next one, to the next one, to the next one, and so on. And that's a very reliable way of doing things because the connection, you're making that connection, it's your infrastructure you're putting in, you know it's going to work. And if there are any faults, you know where to go looking at that cable, you know where the connections are found. Another way of sending that information is each door controller has a network connection. So that means the controller connects to your client's local area network, your computer network, and all the information is distributed through that network. So it's still the same computer, still the same software, but the information is sent from that central location, and it's either sent on RS485 or it's sent on TCP to give it its correct name. TCP can be 2 things. You can create your own local area network. You can put switches in locations and bring that switch, the first switch, back to the PC and connect that way on your own private network. Or if you want to, you can use your client's network if they have one installed in their building and that cuts down on installation costs. Other ways you can connect to controllers, you can connect with GPRS. You can do controllers which have a GPRS modem built into them. So on multiple sites, say you're looking after blocks of flats and you have lots of flats, but they don't necessarily have an internet connection on site. Well, you can put a router in there with a GSM connectivity, and you can send reports through to those controllers remotely from a central hub and add or delete people. And that's a very easy way to have a PC-based system without that network connection. Other connection types would be a modem. That technology is dying out now because of the GPRS, but you can still have systems where you can connect over the phone line and connect straight into the system. As I mentioned, some vendors of power supplies, they make their own cabinets with access control vendors in mind. Now, some access control vendors sell their products in a metal case with a power supply, a one door or a two-door controller. They also appreciate that you may want to cluster all these controllers in one cabinet. So some of these vendors also sell their controllers PCB only, printed circuit board only. And that means you can house these particular controllers in one cabinet, in one box. So we do 3 or 4 vendors who supply power supplies which can house anywhere from 2 to 8 single door controllers. And that's a very popular way of doing distributing power. Another way of distributing power, which only came to my attention recently, is you could have a central power supply, and instead of having to run mains power to each door, you could actually run 12 volts to each door from a central power supply and have local power supplies above the doors, but instead of them being mains powered, they're powered on 12 volts DC. It's a very clever way and a good way to good in the fact that you don't have to run mains cable above a door. You're running low voltage. As long as each controller has a battery backup, then you've always guaranteed some level of security. Obviously, if you're running from a central power supply, you do risk that if the cables are cut to the door, you can't charge that battery remotely. So consider that as a downside. And there we go. We've just covered the basics of what a door controller does, some of the various connections types, and some of the various layouts. Installers rely on ADI. The ADI projects and technical teams offer a pre-configuration service. Any project size, from a single device or to a complex system. Any IP device can be configured from our central hub using our technical and project teams. Having your device pre-configured will save engineers time on site. We can set your IP address, the gateways, and in addition we'll make sure your device has the latest firmware on board. Simply get in touch with your ADI sales contact or email the projects team. Thanks very much for watching. All the products mentioned in this training video can be found on our website. Links are below. Don't forget to subscribe. Thanks very much.